So, hello. I'm going to talk about what we do at Sayara Wireless, which is M2M, machine-to-machine communications, and, well, the way Lua makes life easier for us and for our customers. So, last year I already did a presentation about the development framework based on Lua that we're working on. You can find the slides online at this address. Actually, if you go to my GitHub, to this address, which is FAB13N and WCHOP12, you will get the source code on which I will work during this demonstration. And in the README, you will find the interesting links that I will mention. So you will find the slides from last year. You will find some code that we've already open sourced, and various things that I will mention during the talk. Okay. So last year I talked quite abstractly about what we were doing, and it was a lot of slideware and no code. This year I'm going to show actually some code running and changing, and show you that you can go fast and develop something that works really much faster than with anything else. Of course, I'll still start by talking about and presenting all of this and why we do this, what's the problem we are trying to solve, etc. Last year, we promised to open source what we were working on. We've partially open sourced something, so especially we presented a scheduler which allows to do easy multitasking in Lua, so based on coroutines. So that's something that, that's a different approach to what has been presented by other people before me. So if you go there, you'll already find what we have open sourced, which is essentially the libraries which are not M2M specific. And we are working on open sourcing everything else. We are doing it under an Eclipse public license and working with the Eclipse Foundation. It takes a bit of time because there are a lot. They really want to be absolutely sure about intellectual property problems. So there is a bit of lawyering happening to make sure that everything that's proposed by Eclipse is totally clean in terms of intellectual property. But we're going to open source the rest really soon now, promised. So first question, what's M2M? So that's machine-to-machine communications. That means communicating with embedded systems. So when you compare this to regular networking, we've got a couple of specific issues. First, we are usually communicating with embedded devices which are all around the planet, which are remote and difficult to reach, usually through wireless networks. So working with wireless comes with its own kind of special issues. And the thing that the system we are communicating with usually don't have an operator to fix them, to troubleshoot them. Someone comes, installs it, get away, and that's it. And if the system is stuck, it's going to be really expensive to troubleshoot and very long and very disruptive business-wise. That's it. And of course, usually we are talking about a lot of different systems. Like when you're managing like windmills, for instance, you might have quite pretty big parks. Like for instance, Nespresso is managing its professional coffee machines that were remotely, and you've got them in so many places, and eventually you will have several generations of them. So you've got very large and very heterogeneous parks to manage. So that's a bit of a big numbers game. So Sayara Wireless, we are in the wireless hardware business. So we are essentially building modems. In my division, we're especially working on M2M modems. And we've got customers who are going to build complete solutions with that. I mean, put them in whatever they want to monitor and build up a solution, an embedded solution, a server solution to talk with it and to control it. They will need to build something fairly complex around this to turn it into something profitable. And well, what we want as modem builders, what we want is to have more people who build more solutions faster for cheaper, so that we will sell more modems essentially. So we build a lot of different things. So all of those things are wireless modems, but you can have more or less integration. I mean, it can just be a system of chip, or it can be a complete regularized system that you can put straight away in a car. You can have a lot of GPIOs of input or output or something more limited. You can have Wi-Fi or not, GPS or not. The combination of the robustness, of the speed, and of the kind of IOs you have is going to define a lot of different products. The people who are going to use that, they are essentially people who've got something very expensive, which is far away and which they still need to take care of. So that will be the people who work with energy, like windmills or solar panels, are going to be all around, and they need to monitor it to check how much energy they produce, to know whether there is something to fix on them, etc. All of the people who do vending machine-like system, they've got huge parks, and they don't want to just send someone to check if it works. They just want to be phoned by the vending machine if the vending machine has an issue. And when they come to the vending machine and they want to fill it back, they want to know in advance what has been sold and what needs to be brought back. And the people who sell highly specialized system, like if you're in a factory and you've got a big industrial air compressor, that's something very specialized to maintain and to keep running. The guys in the factory don't know how to manage that. So it's the builder of the compressor who is going to do the maintenance. He's got some of them all around the world, the same. He wants to know when something goes wrong. He wants to know what, and he wants to know that in advance if possible. And you've got the stuff that really are designed to move around. So typically when you've got a fleet of vehicles, you want to know where they are. You want to check what people do with them. That's something. And we also put stuff on shipping containers. When you're moving stuff around, expensive stuff around in a boat, you want to know where it is and when it's going to come, and if it's going to be late for some reason or another, or if it's been lost at sea. That's something that happens. You want to know it really as soon as possible. Utility meters, it's just about when to get your electricity bill or your gas bill or your water bill. You don't want to have someone to go and check every house every month. If the meter can just phone home and tell the power company how much you've been using, that's a lot of time, money, and energy saved. So, if you want to build a solution like that, I mean, none of this is rocket science. Okay, I mean. Many people know how to do embedded hardware. Many people know how to put software on them. Many people know networking. Some people know the specifics about wireless networking. All of those issues, it's easy to find someone who knows one or two of these domains. The difficult part is that it's extremely difficult to find a single company that knows all of this simultaneously. That's what makes it tricky to develop an M2M solution. So, the thing that it's something that is going to become more and more important. I mean, the economic forecasts are really impressive in terms of the number of devices which will be connected with M2M system in the future. And I mean, not every economist agree on how many billion systems there will be in a decade, but they all agree that it will be measured in billions. So that's what we used to call a bubble. And I mean, so you've got that system that's really difficult to program, and for which there will be a lot of demand. At some point, we have to make it easier to work to develop such a solution. And I mean, that's where we come with Lua, is that we want some regular developers. I mean, people, good developers, but not ultra specialists in one domain or another. We want all the good developers, good generalist developers, to be able to build something that works without spending years learning plenty of things that will become obsolete in a couple of years. I mean, like everything software related, actually. So usually, embedded development is about making a seemingly simple thing very complicated. I mean, like the piece of code which is on the left is about sending an SMS in low-level C with a modem connecting to a serial line. I mean, it's 2-3 pages of code just to do that. That's not possible. I mean, if you spend the best part of a week trying to send an SMS, you're not going to build a complete solution in an economically viable way. What you want, I mean, yeah, that's a decent way to send an SMS. That's how it should be, and that's usually not how it is today. And that's what we are enabling, basically. So coming back to this whole list of stuff that you need to do to build the most basic M2M solution. Here is what we try what we are providing to help people building something complete without being a specialist of a dozen domains at once. So of course we provide the embedded hardware. I mean, that's our original business. That's our core expertise. We help people with managing, like getting the right SIM cards, managing the subscription, because if you're going to work with a couple dozens of modem, I mean, it's easy. You just phone them for each SIM card and you put them in the modem, you check that it works, and eventually it ends up working. If you're working with thousands of modems or hundreds of thousands of modems, that's not possible. So you need a dedicated. You need to be interfaced with a network carrier, and you need to be able to handle big fleets of SIM cards at once. We provide the SDK to develop the embedded part, which is actually the core business of the application. That's what I'm going to talk about. So that means providing the API in Lua, providing an agent that is going to handle all of the tricky parts by itself, and providing a decent IDE to work with. Sayara is a main contributor today to the Eclipse Lua plugin, which is called LDT, like Lua Development Tools. And I mean, we make sure that it's easy to develop with Eclipse on our hardware. We provide the backend servers to get data. I mean, it's really difficult to get data, some data which is on your device and field. The thing that you need some magic to happen so that this data comes back to a regular server on the cloud where you can just access it through REST APIs. That's what we do. And you got your device and field, and somehow your data comes in a form which is usable by all web developers. We provide, of course, REST API to get access to those data once they've been collected. And we provide a way to quickly have a UI to exploit this data if you don't want, either before you develop your own front end, or if you can just do without a front end. I mean, if you're happy with a generic front end, you don't need to develop a front end at all. You just take ours. You need to configure a couple of XML files, and you've got a UI that works with no programming. I mean, I mean, that's something that's probably invaluable with Ruby on Rails and all of the other systems which are about faster web development. You need some scaffolding that works immediately, at least temporarily, and sometimes it's good enough just to go to production with that. So I'm going to demonstrate the SDK. I'm going to do that with no Sierra wireless hardware, actually. Why? Because the point is to show that it's easy, so it's all done with stuff that you can find on the net easily, cheap stuff, and stuff that require no specific hardware knowledge. So here is this is a Raspberry Pi. It's about $30 $35 if I remember correctly. You can run a full Linux operating system on it. This is an Arduino Uno. I think it's about $20. Well, it's an open source and fairly simple microcontroller. And around this, we are just putting a couple of sensors, or a couple of dollars each, which are, so those one comes from Seed Studio, so the same shop as Crazy Ivan the robot comes from. The point that it's easy, it's just, I mean, you don't need even any kind of soldering, you just plug stuff together and it works. And I mean, it really requires no hardware knowledge, and you don't even need to know by which way you should handle a soldering iron to get this working. So what I've got here, so this is a relay. That means that it allows me to control anything that's plugged on the main power, like switching on and off a light bulb, a heating system, whatever. I've got a temperature sensor. I've got a light sensor. This is a humidity sensor, and this is just a button, a contact, which can be pressed or released. There are many other possible, just go and look on the net. I mean, there are many sensors that you can find that you can just plug on anything that has got GPIO inputs, outputs. The point that today it has become easy to build your own hardware system with very little specific skills. So our SDK, so as I said, it's based on a scheduler. I mean, we've got a scheduler which works around coroutines, which means that it's easy to launch threads in parallel, to wait for things to get signals from one to another. Well, it's been presented in more detail last year, so if you're interested, you can look at last year's slide and ask questions if you're interested. So we'll start with a very simple application which will just serve a Telnet server on which there will be a Lua shell, and I'll just play around with that, and progressively we will add more things around to turn that into an interesting application. So so this is Eclipse. Eclipse on a tiny screen, which is interesting. At least it's readable. Anyway, so this is my initial application. So I'm just loading the scheduler, loading the Telnet system, starting the scheduler, just printing something to say, okay, I'm started. And here you've got, here I'm actually starting the scheduler. So sched.run is going to load a function as a new thread. And sched.loop is the function that never returns, which just starts the scheduler and runs it until the program exits. So I'm going to run it. I shouldn't have modified anything. I hope it's not Okay, so you see, it works. I got a Telnet running on port 2323. And here I'm now on the Raspberry Pi, so I can do what I want. I can, compute stuff. I can write function like so. Let's say string. Okay, I'm going to wait a bit. End of the for, end of the function. Okay. See, so I got my function that's running. I can interrupt it. So since I'm in the scheduler, I can run the stuff in parallel. So I can do sched.run. Actually, you don't see, but I got autocomplete on the Telnet. Runtime autocomplete. That means that it, as soon as I access a global variable or a global sub value of a global table, I got autocomplete. And now I'm going to run f in parallel. You don't see it here because since it's not running on the Telnet, the print is redirected to the default output. I mean, print only prints on the Telnet if you're running on the Telnet thread. You're running on a parallel thread. When it doesn't know where to put the print, it prints on standard out, so that's on my shell. I mean, that's a task, so I'm just going to launch it that way. So you see, it started again, but I can kill it before the end, and you see, so 1, 2, 3, 4, 5, 6. It was a 7th iteration. Sorry, I've got the control on my scheduler. There is also a system of communication, so it's based on signals. With everything that might be interested can be advertised as a signal. It's got an emitter, which is whatever object you want, and a string which describes which event happened, and you can just subscribe to it to know that it happened. So, and to answer to a signal, you can either wait for a signal. You will stop the thread that does the waiting will wait until the signal happens. Or you can you can put a hook on the signal, which means that you will run a callback every time an interesting signal happens. Like for instance, if I take back my function, okay, I think it's going to be, okay. F, so I'm just going to add something to wait for a signal here. Wait, I'm going to, which means that I'm going to wait for any signal star is for any event. I'm going to wait for any event sent by the string foo. Okay, I'm going to get back the event that has been caught and print I received event. Okay. And now, if we look, so here we've got nothing on the main shell. I probably can get it a bit bigger. So it's still blocked, but now sched.signal foo my event, and it doesn't work. Sorry, pardon? Oh, yeah, okay. Now I'm going to launch the function, actually, parallel, so it's waiting. And now if I launch, okay, I receive the event, my event, and the function is starting normally. Based on the signal, we've re-implemented the usual system. I mean, you can get pipes, you can get mutexes, etc. I mean, all of this is straightforward to implement over the signaling system. And, and so that's it. So the scheduler is already open source. So if you go and look at Lua Sched, you can get, so that's this link. You can get it, you can play with it. It works on Linux. It's probably possible to get it for running on Windows. It does run on macOS. And it can also be ported to some more exotic hardware, but then you would have to do it by yourself. So I mean, this is already working. This is apps. So I don't know. I hope I've still got the network. Well, I'm going to need the network actually. So maybe my Wi-Fi just expired. It might be their problem actually. Okay, so Please don't tell them. Okay. Anyway, so back to Eclipse. Back to GitHub because actually I've still got it locally, fortunately. We've seen the release the simplest application possible. I'm going to start playing with those sensors and actuators because the whole point I want to drive home is that it's almost as easy as dealing with regular Lua variables, and you can get down to business really fast. So I need some shell. And I'm going to jump to this one just to show you the Git is easy. Okay, and if so, maybe I can just show the diff. So patch, yeah. So it's going to be tricky on this screen, but what I'm going to change. So I'm just going to the system is driven through Modbus. So something that's sometimes irritating when you're working with serial protocols on embedded system is that everyone wants to write its own gratuitous variant of a protocol over serial lines. That's really maddening. Anyway, so the closest thing to a standard that exists to exchange variables on a serial line is Modbus. So it's pretty old. I mean, they still call their variable coils and input registers and discrete input and stuff like that, but it gets the job done, and you can find, it's not too hard to find some hardware that talks Modbus, so that's pretty good. You've got also a Modbus TCP variant that can run over TCP networks. So yeah, and here, what happened is that I just looked at Arduino websites, and I found a very generic Modbus slave, so that there had been no need to develop for the Arduino. I can directly run. I can just plug it to a serial port to the Raspberry Pi and get stuff running. So. Okay, so the patch view is just unusable, so I'm going to show the code directly. That's what I want. So this is my application. So you've got an initialization module which is just going to initialize the Modbus client. The data are just where is the port and what speed does it support. And then I got some very simple function, basically a read and write. You see there are almost empty wrappers. You've got a check, so that's just something to check that the first argument to the function is a number and the second is a string. That's a way to mitigate the risks that you have when working with a dynamic language. We like this API because it's simple, it's easy to read, it's easy to maintain, it's no nonsense. Works quite well, and it's got a good self-documentary value. I mean, when you put that kind of information in the comments, sometimes it stays, sometimes it's updated, sometimes it's not updated. Here, if it's not updated, the program stops running, so you tend to keep it up to date. That's a feature. So I've just wrapped the Modbus commands in those functions because I'm going to modify them after. So I wanted to show. So you see, I mean, that's just the one is the name of the Modbus slave. So here the Arduino is called 1. Address is an arbitrary number, and here it's the number of bytes. I want the number of words actually, because in Modbus the stuff are 16 bits long, and that's it. And it just works. The thing that it's a fairly complex exchange with, there are some protocol stuff that happens here, which would be blocking the VM if we were without the scheduler. Here, the interface looks like a blocking API, but if you go down and check deep down, actually it's all event-driven, which means that when I send a request to read my holding register and I'm waiting for the answer, other threads are kept running, and I'm not locking my VM. I don't need to have a dozen VM running on hardware that might not support it. And since everything is in the same VM, communication is ideally easier and possibly messier, but that's up to you. So I'm going to run this just to show that with a couple of lines I've got something running. So I stop the previous one. I restart. Okay, and I got the shell running again. That's not my shell. Okay, and so my module is called M. So it's already initialized. So I'm going to do so to see M dot read. So I don't remember the number of the stuff. So for instance, I'm going to read 6, which is the which is the light to tell me whether it's switched on or off. So I'm going to play with the button. It's going to be easier. So the button is currently off, so it's going to be 0. But if I press it, I'm going to read 1, 0. So you see, I've pretty much got access to my button directly. That's it. So I can write on the system, which means, so we've seen that the light is currently at 0, but I can also change it. So it's 6, but I'm going to put 1, 0 in it, and it should switch on. It did. So I got an LED in addition to the relay, so I can see what I do. And I can switch it back again, and it works. Okay, so we're in Lua. So this is a very primitive interface, but it's easy to turn it into something more usable. So if I go back here, okay, this one. So here it's, there is nothing specific to M2M in my changes. The thing that changed, and this is some, please. Okay, what changed that here? I've put I've put up a translation system. So that means that it allows to translate the numbers into proper names, and it allows to modify the values I used to read. So I've only shown binary value, which were 0 or 1. But usually, when you got physical sensors, are going to send arbitrary value that you need to change into physical values. And by just registering them into 2 tables, so which are read and write, I can pre-process or post-process the data so that they have a decent look in Lua. And they are still usable. They are still understood by the sensor. So if I restart the system with the new sources and come back, I'll get stuff. So m.read. So see, I'm reading my button. So it's been turned into a Boolean. Okay, and if I play with other sensors, like I want the temperature, no, I don't have autocomplete on strings, actually. So it's about, sorry, it's in Celsius. I still don't understand Fahrenheit. And this is the temperature sensor, so you see, I put, I must be thick. Or maybe I don't have the finger on the right position. Okay. This one is easier, luminosity. Okay, and if I hide it, I should read something much darker. So I'm not hot, but I'm dense. That's it. So the next part of the demo, due to the demo effect, is not going to work. I don't know why, but I can't get my data to go through to the server. I wanted to show how to use MQTT. So MQTT is a protocol. It's a broker actually. That means that you can just publish data on it with a pass, and you can subscribe to a pass, and well, you publish whatever you want, and everyone that who subscribed to this pass or to a prefix of this pass is going to be notified about it. So it's extremely simple. It's been designed for very simplistic microcontrollers, typically for power meters, and it's simple to implement. And it's really fast. So if you want to monitor something very easily, that's a good protocol to use. So except that here I can't get it. It's probably because I'm using my PC as a router for the Raspberry. I don't have any wireless system to communicate, and I guess the Wi-Fi router is not really happy with me being a router as well. Anyway, I'm going a bit further. So MQTT. So if we can look at the code that doesn't run. That's not what I want. It's tricky. Okay. Yes, I want a new version. So here I got, I've modified the system with respect to the previous one. I'm requesting all the variables. Instead of reading variable one by one, I read everything in a single request, because the longest part is waiting for the serial line. Once I've got it, so it's much better to ask for everything and sort afterward, at least when you've got something like half a dozen variables like I do. And the point with that is that it's very easy to write a polling loop. So it's that's the main polling loop. So it's just an infinite loop. I'm getting all of the variables. I'm checking whether they changed, and I'm notifying when they actually changed. So actually, I can run that. Just killing the previous version and running again. So the debugger in Eclipse does work with the scheduler. That means that you can still go step by step and thread by thread as you want, and it just works. Okay, it started, and I'm just going to look at the logs, and okay, so here you see it's only notifying when something changes, which means, like, for instance, if I change the button, you see it went from false to true, and if I release it, it's going to go back. And here I got a bug, because if I go in the code, because I've put an action actually on. If you look at the code in the main loop, which I've lost, you see when anything has changed, I notify it as a signal, which means that I can catch the signals and do whatever I want with it, and that's what I do here. So I write an on button change. It takes the event, the fact that it changed, the previous value and the new value. And here you see, here is my problem. I'm still using m.read, and I've changed read into a riddle. So if I put it that way, it should work. So, yes, please. And now if I try again, okay, that's not the most interesting part of the logs. The thing that the log system is generic, so you just give it a display function, and it just I just do log.displaylogger equals print, and that means that the formatting is not perfect. But okay, now false to true is okay, and true to false is okay, and it's been linked with the light. You see, because if as soon as I release the button, the light state changes. Now it was the same window. If I go back and I look at my source code, you see, I get the previous state of the light, and I just invert it and write it back. That's it. But like, it's very simple. It's 2 lines of actual code, and that's the way it ought to be. That's not the way it usually is. So, and in parallel, I'm trying to send all my notifications of change to MQTT, which is my broker is running at eclipse.org, but it's after the first packet is gone, every other TCP packet is dropped without an explanation. So someone is eating them somewhere on the way. Okay, and now I'm going to move to something else. I'm going to show you how it. Until now, I haven't shown anything related to Sayara Wireless system, especially to the backend. So I'm going to stop this and come back to my slides. Okay. The nice thing with M2M application that all more or less do the same thing. So that means that it's easy to help people go faster. You've got some data that you want to get, to format, to buffer on the system, and to send in an efficient way. You want some simple actions to be taken completely locally. I mean, if you don't want everything to go to the server and back to the system, even for the most trivial questions. Either because you're not always connected. Second, because it's expensive. I mean, airtime and bandwidth are expensive on wireless system. It's getting better, but it's still got some way to go. You always need a couple of server-initiated action to shut down something, to ask for a report right now. You've always got a couple of things that you want to initiate from the server, and there is a very important part. As I said, most of the time it's getting someone to go and physically touch the device and field is usually more expensive than the device itself, so that's really something you want to avoid. So that means that when you want to update the business software or the firmware of the system, you want it to happen over the air, and you want to handle it collectively for your whole fleet of systems or for a big subset of your systems. That's easy with a dozen or so devices. If you're in the tens of thousands, it's really a specialist job. So the part about data acquisition, what we propose. So first, we've got all of the standard protocols, and we've got some stuff to help people with the non-standard ones, which means that you've got a framework which helps you go faster when you want to write a serial some custom protocol to speak over a serial line with a custom system. We've got local storage. I mean, when you acquire data, you can keep them on RAM. You can keep them on file if you really don't want to lose them, or if there are going to be a lot of them. So it can be persisted. We've got efficient ways to report them because, I mean, usually, for instance, often you're going to take a lot of data over time, and you know they are not going to move a lot. I mean, like the derivative of your function over time is going to be really small, which means that it can be encoded efficiently if the protocol is designed on purpose for that. Of course, we propose some protocols which do that efficiently. If you're willing to have less precise data, we can encode them more efficiently. So that's really up to you to know how much precision you get and how much bandwidth you're ready to pay. Well, and a couple of other pretty standard things that most people will want at some point or another. And yes, last point is reporting policies. That is, usually, since our time is difficult and expensive and costs a lot of batteries, you're not going to stay on and to push your data in real time. You're going to collect them and send them by batch. And moreover, you're going to fiddle and try a lot of things before you're happy with the way you report them. You're going to change your mind a lot about what's the proper way to report them. So you need to be able to change your policies on a whole fleet of devices and to change it from the server and just to get it dispatched to all of your systems. That's something important because typically when people write their first M2M application, never consider it as a priority, and if they don't have over-the-air software updates, they're pretty much screwed. But then that's a part, I mean, since we've seen a lot of applications being designed, since we've designed a lot of them ourselves, we know the most common traps and we offer ways to avoid them. So we've got some systems to manage to get access to all of the IOs on the system, either directly on the gateway on the main computer or on distributed systems around, because this architecture where I've got a smarter gateway and a more stupid system, which is or more simple system, which is away from the gateway. That's the most common architecture you'll find. So we offer a generic way to read, modify, and monitor the variables and to add new variables in the system. What you've seen in the demo, because I wanted something simple, was just a polling loop. Well, it's simple and it works, and for many use cases that's enough. If you want if you want some more configurable, powerful monitoring system, we can propose something for that as well. And since you've got a whole Lua language on the system, if you just want to wire a reaction to an input and to modify outputs depending on local inputs, I mean that's just putting a couple of lines of script on the system. That's really easy, and it's really cheap to change your mind, and you can just send the bit of script that you want to change. You don't need a full software update. It really accelerates the life cycle of modifying an application and keeping it up to date and trying stuff until you find something that actually works. When it comes to server-initiated action, so of course you can ask for data. I mean, there are standard ways to ask for data right now. As I say, you usually have got policies which say when you want to report data. You can, you can also ask for them right now from the server, and the system is just going to answer right now, which is what you want. We've got helpers to implement generic commands, etc. And we can, all of this works for large fleets of systems. That means that if you're going to send a command to thousands of systems, some of them will fail. You want to know which one, you want to know why, and you want to figure out a solution. Again, you need some support from the server to make it manageable. And well, over the air, I mean, if you don't have over the air, you're going to have serious trouble. And the same. The thing with over-the-air update is that when it fails, it usually fails seriously if it hasn't been done properly. So you need some rollback system on the device to come back to the previous version if you failed in the middle of your update. And again, that's pretty specialized knowledge, and you want a library that you want an agent outside which is going to handle that for you. So yeah, maybe I can show you. Maybe I can show you the system running. I'm just going to get master. That's it. So here, in this version, I've removed everything about MQTT publishing, and I've put our system instead. So that means that if we look, yes, please. If we look at the code, so I initialize what we call an asset. An asset is a proxy for an application. So I create an asset. I give it a couple of callbacks to react to what the server is going to send me as commands. And once I'm happy with its configuration, I'm just going to start it. Okay, so I run it. Okay, and so I got mostly the same thing that I had just before, but if I go here, so I hope it's going to work better. So here you are on the default interface. I mean the one that you've got for free without developing any kind of front end. So again, it's optimized to handle big batches of systems, not for a single system like we are here. It's okay. So here is the asset I'm currently working on. Okay, so it's the same as Eclipse. It's been designed for a slightly bigger screen. Okay, so here you see all of the variables that I've declared. They are here. I get their values. So I can also get through web APIs. I can get the whole history of their previous values. I can't get it by default on the front end because that's not the most common case, but somewhere up there. Oh, no, okay, I think it must be somewhere in here because it's to be done with a whole fleet. But you can get the historic data in details if you want them. So if I come back here, so I got my data, so they are updated. I mean, it's not when normally with MQTT you would have seen the stuff changing at every second, and it would have been really reactive. And when you're doing something like home automation, that's really important to react very fast. Philippe said half a second. That's probably indeed what is called a long time for the kind of things. Here, the point is not to have one device answer in a fraction of a second. It's about having a very large number of devices reacting in a couple of minutes. But it's okay to have some latency as long as you can manage a lot of devices simultaneously. So here I got my values. So normally it should look good, but it's like, and the one that can be written like here, light. I can put that way, and okay, and I apply the setting, and normally my light should be switched on in a couple of seconds. Sorry? Ah. Okay, so here, I mean, on one device, it's going to take much more time than directly from Telnet. But the thing that it would have, the difference would have been if I had 1,000 of them, I could have applied them to my whole fleet as I wanted, or only to those of a subset. I mean, the devices can be sorted with tags, and I can apply my commands to any kind of tagged system that I want. Well, I'm pretty much done with the demo. That's it. So today you've got the services which are not specific to embedded systems are already open source as Lua Sched. All of them are designed, or at least most of them are designed to run with the scheduler. And we are going to we are working on the final stages of open sources. The rest of the system it's hosted by Eclipse. It's going with some other things which are all about. I mean, there is a whole effort toward M2M, which is led by Eclipse. So you've got embedded tools, you've got LDT, so the Eclipse IDE. You've got some server-side system like Paro, which is MQTT broker. And people are under discussion to bring more things that they want to open source around M2M development. So if you've got questions, yeah?
I'll just talk loudly. You're using MQTT bidirectionally? No. So you're using MQTT bidirectionally to send commands to the devices as well, or
in this sample, yes, it was supposed to be. Actually, I have an Android application which should allow me to control the system. Yes, you've got publish and subscribe on MQTT, and well, we've got publish and subscribe on both sides, so we can publish data about what happens on the system, but we can also subscribe to events coming from external applications. Well, MQTT is very flexible, so you can do whatever you want both ways. It goes fast, so you don't have history, you don't have failover. I mean, you don't have the big, the heavy-duty stuff behind, but I mean, it's a very fast, easy, lightweight system. So if you want something lightweight, that's a good protocol.
And do you use that as the transport for, say, pushing firmware upgrades or other objects?
No. We use our own. I mean, we've got our binary protocol, which is optimized to save bandwidth. So for among others for a temporal series, because that's usually what's most expensive. And I mean, and I'm not sure. I don't remember how secure what you can do to secure MQTT exchanges. But I mean, when you are pushing a firmware on your application, you want to be pretty sure about what you receive. I don't know how secure you can be with MQTT. Maybe you can, but I don't remember.
What was the communication link between what you were doing there on the server and the Raspberry Pi? Do you have like a wireless?
No. So here I got. This is serial over USB between the Arduino and the Raspberry. The Raspberry is connected through Ethernet to my computer, and my computer tries to send it back to Wi-Fi with mitigated success.
Okay.
Stop.